Hello, this is a demo of the new assembler feature of OpenCloning. The assembler is a tool that allows you to plan Golden Gate assemblies that follow a particular syntax. To start, go to the Assembler tab, and you have the full documentation in this link if you want to go in detail. For now, I'll just run through a few examples. So the easiest way to start is to load one of the existing syntaxes that are available. So just click on Load Syntax and you will see a list of available ones. You can create your own and load it, and there will be another video for that. But for now, let's load an example. Let's say Golden Pigs. So Golden Pigs has two types of assemblies. First, assembling a transcription unit, and then assembling a multi-gene construct. So let's start with the transcription unit. If we click on transcription unit, we will see the parts that comprise this assembly, and then we have the options of the plasmids that are shipped with the kit. So these are the plasmid you can buy from Gene. If you want to use your own plasmids in the assembly, you just click on Add Plasmids and you can import them by selecting them. So before that, notice how the parts are color-coded and show the overhangs that form. And for example, if this ATG is meant to be a methionine, it's labeled as such. So now let's again try to add our own plasmids here, and when we add them, what we will see is that the valid plasmids, so those that are compatible with the assembly, so they are cut by the enzyme of the assembly, they produce the right overhangs, they would be color coded by their category, which is here, part info, so this one as a terminator, this one as a promoter, coding sequence, etc. And if they're annotated, the longest feature of the part will be displayed here. So for example, this EGFP plasmid has an annotation for EGFP in the part, so it's displayed here. This one doesn't have an annotation for the terminator, and therefore it's not displayed in here. And also, if you have some plasmids that are not compatible with the syntax, such as this random sequence here, then they will not be imported and they will be labeled as invalid. So if I click on import valid plasmids, then I can see here in the list the one I uploaded that is shown in green. So now, how do we do an assembly? So we have to select at least one plasmid for each part of the assembly. So let's pick this promoter, this protein, let's take the GFP, and a couple of terminators. And let's pick a couple of backbones, so AB and BC. And when we click on submit, this will request the sequences, in this case from a gene, except if we have provided the files ourselves, and we will see a list of the different assemblies that have been produced. Then we can click on the I button to see the individual assemblies, and we can see in this case the inputs for the Golden Gate assembly, the Golden Gate assembly reaction, and the product. And then we can also click on the I here to see it in the sequence tab in detail in the editor. Now if we go back to the assembler and we click on download assemblies, we will get a file that contains all the zip file that, when we decompress, has a folder with all the assemblies that we have generated. So the files are named with the parts that were joined to produce them, and then you also have a tabular file that has the information of each assembly, and each assembly has a number, so they start with 1, 2, 3, and they match the rows in the table. So that's it. And for each of the assemblies, you get a GB file that you can open in your favorite editor, and you also get a JSON file. So in case you come back to OpenCloning, you can load the JSON file here and see the history that of the assembly. So that's it. Thanks for watching. Give it a try. If you have some feedback, let me know. And if you want to keep updated about OpenCloning and its features, go to About Newsletter and subscribe to the newsletter. Bye.